welcome to The Explainer. I am absolutely thrilled you're here today because we are going to unpack a truly fascinating document. We're looking at the STEAM chip concept, specifically this highly ambitious blueprint put forward by Luis Manuel Ortiz Inostroza. Now, as your guide, my job isn't to tell you if this is science fact or science fiction. My job is to impartially break down exactly what this source material proposes. And let me tell you, the claims made in this blueprint propose a total reimagining of how we build, power, and use technology.
Right off the bat, to kind of anchor us, let's look at the official project birth record straight from the source. It reads, Project Steam Chip Concept. Birth date, Friday, May 8, 2026. Status, officially marked as the creation date of the idea. Notice that date? Yeah, 2026. We're looking at a document that frames itself as a sneak peek into a proposed technological future. It's written as a forward-looking declaration, laying out a totally new paradigm for the semiconductor industry.
So here's our roadmap for this explainer. We're going to cover 1. The STEAM concept, 2. Computing power, 3. Eliminating tech pollution, 4. Desktop chip fabrication, 5. The mesh network revolution, and finally, 6. A distributed tech future. Let's dive right in. Kicking things off with sections 1 and 2, the STEAM concept and computing power. Because let's be real, performance is the heartbeat of any microchip, right? We have to see how this STEAM blueprint stacks up against the current heavyweights of traditional computing, like NVIDIA or Apple, and the bleeding edge of quantum computing. According to the document, the STEAM system visualizes its own dominance by outscoring both quantum and traditional industries in nearly every single category out of 100. Compute power, 100. Energy efficiency, 98. Size factor and repairability, a perfect 100. The only area it acknowledges quantum might still hold a niche is in highly specialized mathematical speedups. Otherwise, the blueprint claims a clean sweep.
Let's actually ground those scores in some hard numbers. Today, a top-tier traditional GPU pushes about 3.96 petaflops of compute power. But the blueprint? It claims its Steam SD Mini tier, which is literally the size of a standard SD memory card, would hit 103.5 quadrillion operations per second. The document explicitly states this is 26 times the performance of current top-tier NVIDIA chips. 26 times.
And remember, that was just the entry-level tier. Get a load of this number. 4 times 10 to the 51st power operations per second. According to the blueprint, this is the speed of the quad-engine tier. To put that into perspective, because honestly it's hard to even wrap your head around, the text claims this is an octillion times better than current quantum models. An octillion. It's a level of raw compute power that pretty much defies our current understanding of physics and hardware limitations, presented here as the total cornerstone of the Ortiz and Inostroza design.
Moving right along to section 3, eliminating tech pollution.
Because as we all know, raw performance doesn't mean much if the environmental cost is destroying the planet. The blueprint spends a ton of time on this, detailing how it proposes to completely eliminate traditional tech pollution. Traditional semiconductor fabs, those massive industrial factories, use millions of gallons of water every single day. They emit megatons of CO2 and rely heavily on toxic gases and heavy metals. The STEAM system, by stark contrast, claims it will use less than 1 liter of water per day, 0 toxic gases, and it relies entirely on all carbon materials like graphene and diamond. Absolutely no heavy metals and no forever chemicals.
And then there's the energy footprint, less than 1 watt. Think about that. That is less power than a tiny little LED nightlight. The blueprint claims that by using something called a passive diamond cooling dome, each chip needs sub-1 watt power. Compare that to the 400 watts to 10 kilowatts that current traditional GPU clusters devour, or the massive megawatts of power required to supercool quantum computers to near absolute zero. If accurate, a sub-1 watt supercomputer chip would completely eliminate the need for the massive cooling towers and power grids currently propping up modern data centers.
All right, section 4, desktop chip fabrication.
This is where things get really wild. The blueprint shifts from just hardware specs to a total David versus Goliath manufacturing revolution, taking chip fabrication out of a $10 billion megafactory and literally putting it in your living room. So, what would it cost you to make one of these chips at home? 85 cents. Yeah, 85 cents. The idea is that instead of relying on massive global supply chains and incredibly complex photolithography machines, STEAM chips will just be printed on desktop machines using cartridge-based carbon ink. The cost of that ink to produce one chip? Just 85 cents.
So how does it handle e-waste? Right now, if a chip breaks, it's pretty much garbage, destined for a landfill or requiring complex, rare metal recycling. But the steam blueprint proposes a closed-loop life cycle. Step 1, you take your failed or broken chip and literally grind it down. Step 2, you reuse that carbon dust as new printer ink. And Step 3, you just print a brand new chip with the exact same geometry. It's basically an endless reprint cycle that the document claims will wipe out electronic waste entirely.
And it doesn't stop there. The blueprint outlines a completely decentralized microeconomy. It imagines a world where anyone can be a chip manufacturer. Revenue streams include selling the printers themselves, which would go for around $500 to $2,000, selling ink cartridges, licensing architectures, service contracts, all of it. Imagine 800 million smartphone users and local mom-and-pop shops suddenly empowered to build and sell custom supercomputers on demand.
Next up, Section 5, the Mesh Network Revolution.
So far, we've been talking computing and manufacturing, but the blueprint also makes some pretty surprising telecommunications claims. To explain how these steam chips actually talk to each other, the source introduces something called whale language logic. The document defines this as a super dense, adaptive, and basically unhackable encoding pattern used to optimize data transmission across the network. Paired with that diamond dome we mentioned earlier, this logic system is claimed to totally blow our current radio frequency protocols out of the water.
And the practical application of this whale language logic? It's huge. Traditional telecom relies on those giant external radio towers, right? Which means limited coverage and, let's be honest, paid carrier monopolies. But the Steam network claims its localized power is so strong that your phone itself acts as a radio tower. By linking these devices together, it creates a user-controlled peer-to-peer mesh network. According to the blueprint, a city of phones simply becomes a city of radio towers, bypassing the whole traditional telecom infrastructure entirely.
Which brings us to Section 6, a distributed tech future.
We have definitely covered a lot of ground today, so let's quickly synthesize these massive, paradigm-shifting claims. The Artesia-Nostroza blueprint is pitching 26 times better compute power than current market leaders, and operating at less than 1 watt of energy, all housed in a chip the size of an SD card. It claims you can print these at home for 85 cents a pop using closed-loop, zero-heavy metal carbon ink, and finally, it claims these chips will form an independent phone-as-a-tower mesh network. These aren't just isolated ideas, they interlock to propose a totally new, self-sustaining technological ecosystem.
The official declaration actually ends with this really powerful excerpt. Its stated goal is ending the era of gas-guzzling, centralized, toxic chip manufacturing. Now, regardless of where you stand on the engineering feasibility of, desktop-printed sub-1 watt supercomputers, you really have to appreciate the sheer ambition here. The blueprint identifies the biggest pain points of modern technology, cost, pollution, and centralized control, and pitches one singular, unified alternative.
Which leaves us with one final, pretty massive question to ponder. If the Artesia-Nostroza blueprint actually becomes reality, will it truly end the era of centralized, gas-guzzling tech? It's the kind of question that really challenges what we accept as the limits of technology today and what might actually be possible tomorrow. Thanks so much for hanging out with me for this explainer. Keep questioning, keep learning, and I'll catch you next time.